going to go ahead and welcome to our virtual stage. I hope I say this correctly, please correct me. Ajit Kulkarni, who is the engineering manager at TC Energy. You can go ahead and turn on and share your screen. I'm not seeing you on my screen, but I'm probably just, yeah, my view. There we go. Okay, pipeline. All right. Welcome.
Thank you. Can you hear me and can you see me, right?
Yes, I can hear you. I can see you. And so I am going to dip and I'm going to let you take it on.
Awesome. Thank you very much. Hi, good afternoon, everybody. My name is Ajit Kulkarni, and I want to talk about pipeline safety today. So before we proceed, I would like to pose questions. Question number one. The answer is yes. Most of us have natural gas for mainly two reasons. Number one, cooking our food, and number two, making our houses warm. The next question I had was, do you know how you get the natural gas in your house? There were many answers, or a couple of options I had. The correct answer is through pipeline. And number three is, do you know the safest way for natural gas transport from the producers to the customers? And the answer to that question is pipeline. The pipelines are everywhere. So I know most of you probably do not know this, but I'm going to talk about this in a little bit. How the pipelines are the safest way for natural gas transportation. So just a quick agenda. I would like to talk about myself, then talk about TC Energy and the pipeline safety. Then my contribution to TC Energy is I work in the engineering team to design the compressor stations, meter stations, and the pipelines. So I would like to talk about what different processes we follow, what different components or critical components we have, and then what is my contribution to make these pipelines safer. And before I leave today, I wanted to provide you some information about the pipeline markers and the leak prevention. So my name is Ajit Kulkarni. I have completed bachelor's in engineering with a major of mechanical engineering. And then I have also completed graduate studies or MS in industrial engineering from Texas Tech University, Lubbock. And I've also had the professional engineering examination in thermal and fluids. So from childhood, my passion has been playing with different types of machines. My parents used to buy the cars or those kind of toys for me. First thing I would look is how do I disassemble it. I remember an incident when I was in high school, and me and my older brother, we disassembled one of the my dad's motorcycle, and we didn't know. We cleaned the carburetor, we made sure that everything was done, but we didn't know how to assemble it. So we just took those into pieces and took it to the car mechanic, and he was just looking at my face. So I have always enjoyed the physics and math, and I'm using those subjects or those teachings that I have done in my engineering school or my high school in my everyday life here at TC Energy. So I have currently I'm the engineering manager at TC Energy for the growth projects, and I have about 15 years of experience in projects, engineering, compressor station design, design of the compressors. So just a little bit about TC Energy is, we are in the business of delivering the energy that people need every day, safely, responsibly, collaboratively, and with integrity. As you can see, TC Energy is one of the biggest companies in North American for transportation of energy. We have about 56,000 miles of natural gas pipeline in Canada, US, and Mexico, and we contribute about 1/4 of the natural gas transported in North America every day. So why do we need pipelines? The pipelines bring us the essential energy that's required. We all need energy for charging our smartphones or smartwatches, to charging our electric cars like Tesla battery. So the demand for energy is ever increasing, and pipelines are the safest way to transport that energy. There over 99.999% of all the pipeline deliveries are made safely each year. Pipelines are about 4.5 times safer than the rail, though both are equally safe. Just to give you a comparison between what other means of transportation of these pipeline would be, to move the volume of even a modest pipeline, it would take constant line of tanker trucks, about 750 per day, loading up and moving out every 2 minutes, 24 hours a day, 7 days a week. And a road equivalent of a single pipeline would be a train of 75 2,000 barrel tank rail cars every day. So these alternatives would require many times the people clog the air with pollution and prohibitively expensive with many more vehicles on the road, making it unacceptably dangerous for all of us. And just as pipelines have robust operations with, and integrity management programs. Some of the organizations that regulate these pipelines, PHMSA or FERC, Federal Energy Regulation Commission, the regulation commissions have standards and specifications that are, equivalent to any other countries in the world. So pipelines are everywhere, and as you can see, this is the right of way. This is how the pipeline operations are carried out. It's called the right of way. It contains welded steel pipe, approximately 1/4 to 1/2 inch thick, and the pipelines are buried about 4 feet deep below the ground for oil and about 3 feet for gas. Under navigable waterways, they're about minimum of 4 feet. So these pipelines operate at about 400 to 1,000 psi, and some of them operate at higher pressure, and require booster compressor stations in order to maintain the pressure for efficient transportation. So some of the project that I'm working on has a producer in West Virginia or Appalachian region or Pennsylvania. So in order for the natural gas from the producer to customers here in Louisiana or Texas, we have many compressor stations after every 30, 50, or 60 miles of pipeline. So now you can see a typical compressor station layout on the screen. So starting from, this is the pipeline, and starting from here, this is where the gas enters into the compressor station. This is the filtration unit, and then goes into the compressor building. There's a compressor here, and then goes into the after coolers if required, and then comes back here. So the different critical components required for the pipeline compressor station are tie-in valves, where we have a pipeline and there is a valve that we tie into the compressor station so that we can close the valve, block off the compressor station and flow through the pipeline. We have the filtration of the gas. So the compressors that we use require the gas to be very clean, and it is a requirement, a regulatory requirement for us to maintain the pipeline quality of the gas. And that's why we have filtration units or filter separators, we call them, which have cartridges or vane packs that remove the liquids or solids. And the efficiency of the filtration units we use are about 99%. Then it goes through the compressor. We generally use reciprocating or centrifugal compressors. The reciprocating compressors, operate on a principle similar to what we have seen, what you have seen in the automobiles, where it's a piston cylinder. The gas is compressed inside the cylinder by the piston, and then whenever the outlet pressure of the gas is reached, the gas leaves to the discharge side. With a centrifugal compressor, there is an impeller that's rotating at very high speed, and that whenever the gas goes into the impeller, that kinetic energy is converted into the pressure energy by the Bernoulli's principle, and that higher pressure gas, which is in the volute or the stationary section of the compressor, is then driven to the outlet side of the compressor station. As you can see here, this is a typical skid for a compressor. This is a centrifugal compressor. This is compressor, and it's driven by this prime mover. It can be in this case it's a gas turbine, or it can be driven by electric motors. And as you can see, these are the other types of instrumentation or control panels that are required. So the choice of electric motor or gas turbine depends on where the station is, availability of the electric power, and many other factors. As you know, whenever the pressure of the gas is increased, one of the side effects is that the temperature of the gas increases as well. And we have to maintain strict guidelines for a gas. Whenever it goes to the pipeline, it has to be below those temperatures. So we utilize after coolers, which are like the aerial coolers or the fin fan coolers, to cool down the gas. And as you have seen here, this is the type of different types of piping that we use, and there are different types of standards we use, ASME B31.8 or B31.3. We also make sure that the pipeline has done the vibration study or the stress analysis in order to make sure that there is that we're designing for long term, 20 to 50 years of operation of these facilities. So let me go back again, sorry. Whenever the gas enters into the facility, we have emergency shutdown valves, or we call them ESD valves. Anytime there is a mishap or any incident within this station, any operator can go and press the ESD button where the blow-down valves are operated, and the entire gas in that facility is blown down safely, so that the facility is isolated from the pipeline. So that's one of the safety systems. The other safety systems we use are different types of instrumentation, control panels, and we use the pressure, temperature, flow types of transmitters. And anybody, if we see that there is an issue in the pipeline, that if there is a the pressure between two compressor stations is less than or 2 meter stations is less than what it is supposed to be, we have means and measures where a gas control technician from Houston can shut down the compressor station, shut down that pipeline to further investigate that incident. Apart from that, we have different utility systems such as building heat for the colder areas, electric generators, so that we can still continue running in case of the utility power goes off, and the air compressor for the compressors to run. So how does TC Energy makes the pipeline safer? TC Energy has extensive pipeline maintenance program to monitor, inspect, and repair our pipeline facilities. The regular maintenance activities are aerial patrol, We regularly inspect the pipeline route from low-flying helicopters and airplanes. The pilots look at the outside, the outside hazards such as unauthorized activities, soil disturbances that could affect the integrity of the pipeline system. We also have leak detection systems. We have sophisticated computational, leak detection systems that are used in addition to the visual aerial patrols to identify leaks on the assets. We also use cover surveys where we investigate the areas where we suspect wind or water erosion may have reduced the depth of ground cover. We have to maintain the 3 feet of ground cover according to our regulators. We also use the geotechnical monitoring, which is, our pipelines cross thousands of bodies of water and significant slopes. All of these are monitored for erosion and movement during the aerial patrol. More active slopes and streams are monitored, thoroughly by a variety of survey techniques. We also have hydrostatic testing. We can verify the integrity of pipeline by removing the natural gas from the pipeline and then replace it with water. Then we increase the pressure of that water to way higher than what the normal operation of the gas is. And we check for any leaks. And if there are leaks, then we either repair or replace those affected sections of the pipe. We also do inline inspection, which is called the pigging. So the specialized internal inspection device is called the smart pigs that have GPS devices on them, where they flow through the pipeline, and we can collect the data and then analyze the data to determine if there are areas of concern requiring further investigation. We also do the investigative digs where we conduct, based on the data analysis from pigging and the other information, we go to particular sections of the pipeline, we excavate those areas and make sure that we look at those anomalies. We also have different valves that are on the stations or pipeline, and we have monthly or 6 months or yearly maintenance activities of different types of valves depending on what the function of the valve is. So we use top quality steel and welding techniques throughout our natural gas pipeline systems. We take additional safety precautions where pipelines across roads, railway trucks, waterways, and the areas of higher population. During construction, as you can see, this is a typical welding process. All welds are checked for X-ray and ultrasonic testing to protect against corrosion. The external pipe is coated for the corrosion. During the operation, we use a very low electric current called the cathodic protection to protect the pipeline against any other external corrosion effects. We also monitor the pipeline 24 hours a day, 365 days in a year by highly trained TC Energy employees from a computerized control center. We call it gas control. And then from there, they're able to detect any changes in the pressure along the pipeline and ensure that all facilities are operating properly. We also use the environmental practices that, the site-specific environmental protection measures are incorporated to ensure the equivalent land capability is maintained. At TC Energy, this includes minimizing and mitigating the effects on soil, water, wildlife, and vegetation. So before I conclude my presentation, I wanted to give you some idea of, you guys have seen these type of markers, in your neighborhood or in your backyard. The information that's contained on those type of markers are, the emergency contact number of the pipeline operator, product being transported, and the company name. And so just in case, how do you detect the leak of the pipeline of the natural gas. There are three S's: smell, sound, and sight. Um, Sometimes, or some of the fluids, the gases may not have the odor in them, but some of the do's when you recognize a pipeline leak is, take immediate action to ensure that you're in the safe location, including, being uphill and upwind of the leak if possible. Unless following sheltering in place, and then go to a safe location, call 911, and then the pipeline operator's emergency number. Some of the don'ts is do not walk or drive into the vapor cloud or towards the pipeline. Do not introduce any ignition source like a match, lighter, car, or anything that can, create a spark. And whenever you are at a safe location, then you can call the telephone. One of the most common incident, or in pipeline accidents, is digging. Whether you wanna, you are going to put a pool in your backyard or install a new sprinkler system, or you have some kind of digging going on, make sure that you call 811 before you dig. If you call them, just give your information, what you're planning to do and where you are, and then they can provide you if there are any pipelines in that area that you need to be aware of. So with that, I would like to conclude my presentation. Thank you very much.
Yes, thank you as well very much. That was very, very interesting, and I learned quite a bit. I have a lot of curiosities about this myself. We also have some questions that, coming in from our educators, so I will get started with that. And also a lot of thank yous already coming in. So thank you for me as well. Our first question, when an issue or a detection has been noticed or picked up by the electronic monitors, how does TC Energy respond? And it says, of course, the questioner says, of course, we assume that it changes based on each issue. And there's a second question, but I'll save it for after. So I guess, first of all, what is the response to a notice from an electronic monitoring?
So we have, electronic monitoring at the gas control, as well as we have different types of instrumentation at the compressor stations. And whenever compressor stations have pressure, temperature, flow, there are guidelines of what is the normal operating procedure for those measurements. And if the measurement goes above that window, then there is an immediate, stop of the compressor, and then we blow down the compressor station. If there is a leakage that's been, found or found by the gas control, they also shut down that there are mainline valves after every 30-40 miles. So we detect the location, we close the valves, and we evacuate the gas to make sure that that incident is not going to propagate along the pipeline. And we have emergency management. We have emergency teams all across the pipeline that, in matter of hours, the emergency responders will go to that particular site.
And so I have a bit of a follow-up question about that. In that response, in terms of mitigating the issue, what types of, is it a material response? Is it an absorbent? Is it what does the initial response look like?
I'm sorry, I didn't understand the question. What type of response?
So if there's a problem and if a leak begins, even if, say, everything is shut down immediately, suppose there is some spillage, when humans get on the scene, Do you know what the initial plan of attack is in terms of how that oil is cleaned up immediately, or how that product is cleaned up immediately? Like what substances are used?
I do not know that information, but we have I work in the initial design
Right.
of the compressor stations. However, I know that the environmental responsibility is something that our team, our company takes at heart. Safety is the number one value that we all have. So I think whenever they go to the site, they assess the situation, and then after that they take measures for cleaning up, whether it's a spill or anything of that sort.
Okay. There was a similar question, and so again, this may be have a similar answer. How would TC Energy remediate natural gas leaks into soil?
So yes, the disturbed soil needs to be replaced with new soil in that case, if there is a soil disturbance. Okay.
Also, this is kind of in the same vein. I guess a lot of us think about, primarily as much as you spoke of safety, and that was really reassuring and affirming. I had no idea there was so much that went into that. But this question is, how does TC Energy in particular plan for natural disasters, especially on the Gulf Coast and that sort of thing? There's got to be plans, right?
Oh yes, yes. So I'm working on a project in Lake Charles, which went through 2 different hurricanes. The third one was going to hit, but we were lucky. We have procedures for operations, and we monitor the weather. We have procedures to make sure that whenever a named hurricane occurs or the higher wind velocity criteria are made, we have a procedure to evacuate the site. We basically, depending on what is the severity of the incident, we lock the site, make sure that everything that's loose is collected, safely secured, and then our operations evacuate the site. And then gas control can start or stop the compressor or any other equipment based on the need of that particular or the severity of that incident.
Wow. So that kind of, again, this is sort of a question of my own. I'm wondering, you may or may not be able to answer this. I'm wondering if you could compare TC Energy's pipelines to perhaps other unnamed industries. Is there anything that you do differently, or that perhaps places your safety measures in a different category than perhaps some competitors? It seems like you've really covered the bases in terms of addressing these mitigation strategies.
Yes, so I do not know what other operators are doing, but I can tell you what TC Energy. So our pipelines are regulated by FERC. These are independent organizations, FERC and PHMSA, Pipeline and Hazardous Materials Safety Administration. And we make sure that our standards, that TransCanada or TC Energy has our own standards and specifications and operating procedures. And most of the times they meet those industry standards, or they go above and beyond those industry standards. So this is the way how we can make sure that our operating procedures, our design standards are I would say, exceeding than the industry standard.
That's really interesting. Thank you. I think what is trying to be asked here is, and this is not I don't know, again, I don't know if this is addresses exactly the engineering of the original components. But in terms of placement of pipelines, obviously there's controversy over placement of pipelines in terms of things like protected wildlife you mentioned, even in some cases, Native American sacred sites. Does DC Energy take these things into consideration, particularly, you mentioned environmental aspects?
Yes, yes, very much so. Sustainability is something that it's one of our core values along with safety, and we make sure that the 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 pipeline and the routing of the pipeline at the early stage, whenever my team works on those projects, we utilize the guidance from the FERC agencies and also our neighborhoods, because we as I mentioned, we want to be good neighbors to wherever we go. We also take care of or evaluate the different impacts of the pipeline going into those areas that you mentioned. So yes, those are very, very important items that my team works with our environmental team and our community outreach team to work with the neighbors that we're going to pass our pipeline through.
That's really wonderful to hear, and I think probably very reassuring for our well, for all people, but especially for our environmental science teachers out there and biologists, etc. I think it's really unique, maybe that you do have that interaction between the teams. So I appreciate that. I think we have one more question here, and then we'll be able to wrap up. So you did mention that your standards are equivalent or exceed not only our national PHMSA guidelines, but also equivalent to elsewhere in the world. Do you think, and this is more of a your opinion question, do you think that the world as a whole should take any different approach to fossil fuels or to the transmission of fossil fuels, how they're stored, how they're transported, etc.? Or do you think that the present standards are kind of, are we at the maximum capacity of what we can achieve?
I think our standards within US are I would say we are industry leaders, and this is my opinion.
Yes, yes.
Working with some of the other countries, or looking at or working with some other customers or vendors, we consider ourselves, and we take pride in making sure that what we do meets our company values, safety, integrity. We also know that today's quality is tomorrow's safety. So we make sure that we are paying attention to the quality of the equipment we use and also the work we do. Now, whether this is the top ceiling or not, I do not know that, and I don't think anybody can know. However, we have environmental scientists, we have different subject matter experts in the industry forming the administration of FERC and PHMSA, who provide the guidelines for the pipeline transport companies like us. And I think they're also considering United States as well as the other world and the effects or the impacts of fossil fuels on this. However, as I mentioned, we still consider pipeline as one of the safest way how we can transport the energy.
Yeah, I agree. I've done some research of my own, and because I was curious about this upcoming presentation, and I was really, honestly, I was surprised that pipelines are safer than in terms of exposure. Automobiles, airplanes, various other things. Pipelines are actually the safest transportation method for fuel. And so, considering that the majority of us still are using these fuel sources,
Right. Yeah.
the approach that you're taking is really unique, and I'm glad to hear it. I see that it looks like one of your colleagues has written into the chat box. Thank you. Uh, Environmental team monitors environmental impacts and works with various teams to minimize environmental impacts via best solutions at the time. And also, we have an Indigenous relations team that works directly with Native American tribes no impacts from the operations. That is wonderful to hear. I'm sure that's very valuable information because, and again, not to overtalk the issue, but often what we get from either news media or sometimes even our scientific sources is one-sided. So to hear it from the industry is really very valuable. So I appreciate that you have taken time to answer a lot of our biological questions in response to your engineering presentation and and also the aspects of your company, such as safety, integrity, community, and that's really valuable information for us all, and gives a brand new perspective. So thank you very, very much.
Yeah, and as I mentioned, what brings me, or what makes me, go to the office every day in downtown Houston is our TC Energy's the way safety and compliance are considered to be, in our blood. We make very, very tough decisions if it impacts our safety. So that's what motivates me every day come to the office. So
that's wonderful. I'm really glad to hear that. And again, I'm sure our educators have really gained a lot of knowledge from this presentation, and it's something that they can take into their classrooms, and that I, as an educator, certainly would have as well. So with that, I don't see that we have any further questions unless there's anything else. Some thank yous. Thank you for your information. Thank you for being here. So again, I'm going to say thank you. Earlier in the evening, I mentioned our sponsors. Again, I want to thank our sponsors, the Akamai Foundation, Amgen Foundation, Boeing, Edward T. Bedford Foundation, Lockheed Martin, Resolute Tissue, TC Energy. Welcome and thank you, Materials, and WestRock. And with that, do you have any further comments that you would like to add?
No, thanks for having me. I appreciate giving me the opportunity where I can share, my passion with the STEM teachers.
Absolutely. I can tell that through how you've spoken, that you truly love what you do, and that you represent it well. So we appreciate you being here. I want to wish you a great evening, and to all of our educators, a great evening. And thank you again so much. Everyone feel free to get in contact with us. We will be in contact with you again soon with more information. All right. Have a great
Thank you.
Bye.
Bye-bye.